Hello and welcome again to Steve's Long-Stay Workshop, where things come to be looked at when they be looked at elsewhere. And Chris from Rotherham came by yesterday, and he bought 5 radios with him. 2 have gone back working on always simple things to do, sort them out because he wants to learn, which is always a good thing. 3 of them we couldn't do anything with, and so he left me for to sort out. So let's get on with them and sort them out. And these videos, Chris, by the way, this is show you what I've done with them, and also obviously if you teach through the trade as well, so everybody can get something else from this as well as you. 2 of them, this one and the Vidor over there, are battery valve sets, and there's a transistor set over there, an Ultra Transistor 6. So let's get going with the first of these sets. This is a Matador. I don't know quite what Matador means in this case, but that's what they are. So in the back here, it looks very much like that Fidelity. Hang on, there's a label there. Hang on, I'll have a look at that and see if it gives me any clues as to what this thing is. It because I think I might well need a manual for this, but we'll see. It's a Berwick, which is basically ever ready, Berwick. Most of these went abroad, but some were available in Britain as well. It's the same set as the other one you got. That was it a Sky Princess you had? It's the same thing. So let's get in and let's take a look. These sets, by the way, they use the D series of valves, D, L, D, K, etc. And all the rules apply with this. This actually is very much the same as the that Princess. So let's have a look. First of all, of course, with all these sets, they take 2 supplies. They take one for LT, that's battery, one for HT. So we'll start with the HT and find out what that is. All these sets, by the way, 90 volts HT and 1.5 volts LT. Any different, I will let you know. Now, one of these should go straight to chassis. Okay. That one, okay. And another one of these should also go to somewhere approaching chassis as well. What should do anyway. Let's have a look. There you are. Okay, so that's now with these sets also, just for the record, that one's going not saying nothing. Okay, that was saying nothing. Okay, well this could be because a lot of these sets, what they do when you switch them on, they immediately come on. So the first thing you check here is that arrangement. It is a common thing with these. So anyway, so that one goes to chassis. Okay, one of these goes, or should go, 9.07. Okay, so one of these will be okay, fine. So if we take out the DL96, which is this one here, it's the DL96. They're the later ones, although you can, to a certain extent, swap them over. So if we look under the chassis here, I just turn around so you can see. Yeah, as you know, I check this thoroughly. So now, so one of these should go to chassis, I hope. That one does, okay. And that one does, okay. Which means also they should be around here. something else. No. So that goes to chassis. That's chassis. That I think should be chassis. It is, and so obviously black is chassis. Okay, so black is chassis. Okay. So now one of these therefore is going to be HT 90 volts, and so that doesn't help us, does it? Okay, not to worry. I'll okay, fine. Okay, looks like there should be two links to HT on a pencil valve. One is the screen, and one is the pencil. So we'll go through again and we'll find out which one is which. By the way, with these also, don't forget that the transformers on these sometimes do fail because of the what gases the batteries give off, so always look for that. Okay. So is it going to be somewhere down here? Okay, that's there. Okay. Now at this point, you get on the phone, not to bring anybody up, but look up the valve and get the pins. Okay. I use a valve museum. Okay, so it's so therefore pin 2 is the anode. So what is this one here? Okay, so that will go to there, to there, and that's not doing anything. Okay, fine. Okay, well, let's see what red does. By the way, you can do all these sort of things without putting power through the unit, which is always safer to do if you can. So, is that going to there? No, it's not. Okay. Right, okay. Well, I'll. Put that again. This isn't the easiest thing to work on, but never mind. Well, again, we'll find out. The 2 is this pin here, so this pin here should go to there. Okay, so basically all I'm doing at this point is working out which of these wires here are which you have to do, because we can't get the batteries for these anymore, and so you have to do the old PP3 trick. Unfortunately, that is the way of the world. So basically all we're doing here is getting these four leads, and one of them is HT, and 2 of them are HT, and 2 are else. So we'll try that one, and again we'll try and see. It doesn't do anything either. is this one going to have to come out of its case and be looked at? I think it is. So that comes out for now, and let's work out how to get this this beauty out of its case, shall we? Because it's going to need to come out of its case. So we take it these two on the front here like that. And does that give us any? No, it doesn't. Okay, not to worry. We'll there's some more here in the back, so we'll take these off as well, and hopefully it should come out either forwards or backwards. There are various things that happen with these radios that give problems, so you have to really be prepared to do them all as necessary. These sets are a bit different to normal range radios, as we saw, but just take them out of the case and have a good look and see. Does that? Ah, there we are. Right, okay, so that's doing something. Okay, fine. And there's one here. Basically, I'm going to try and get this chassis, this PCB, because there are going to need to be components changed on this board, so it's going to have to come, whether it likes it or not. And I get the impression it doesn't actually, but there you go. By the way, with these sets, don't connect the HT up to the LT, because if you do that, these valves will blow instantly, because on these sets they are in parallel, and that means that they'll all decide to commit harry-carry if you do. And really we don't want that sort of thing happening, do we? No, of course we don't. So let's avoid it if we can. If it's not happened already, of course, which it does. You know, it does. You know, there's no way of avoiding it. It does. Actually, Berwick bought out one of these sets which had VHF on it as well. I have got one, and at some point I will be having a look at that as well. Because I must admit, I do like these sets, mainly for their challenge value. Yeah. So that goes onto there. So if we now take these antenna screws out here. By the way, some of these sets have an antenna and some don't, and the ones that don't have an area in the lid, and in many cases that area is part of a tuned circuit. So in those sets, particularly that Vidor over there, the one that I had some fun with recently, they do tend to make it an interesting situation to work around. Just so you know. Where's that gone? It's there. Okay, fine. Will it now come out? Will it now come out and work? Even. Ah, right, we're getting somewhere. This case has got all these various wooden bits holding it in place, you know, so you've got to be prepared for a bit of a, not a fight, never fight a radio, just basically be patient with them. No matter how much a set might get up your nose, the key is always patience. Always. Anyway, that's enough for me to look around, so let's look around. Okay. Right, anyway, I'll test the valves on that in a minute on the heater, on the heater. But for now, like I said, that's the that's the deck. Okay. This is probably going to be the heaters. Therefore, there are in fact two decks on these, as it were, and the reason for that is that there is a resistor between the two. This is because on these sets they have the cathode and the heater on these is all one pin, so they do tend to and pencils need to put the cathode on the grid voltage on grid 1 lower than the cathode. On main sets, usually with the cathode resistor on these, it generally makes it lower on HT, so that's what happens there. Okay. Anyway, so one of these is therefore going to be HT and one is going to be LT. So that goes to there, and that does now. Okay, right. And this too is just basically saying no to us for some reason. That's the anode of the pentode, and I think, let me check and make sure. And next one is G2. So anode and G2 both go up to the top. and that one should go up to the top. But so I'll feed, if you look back now and try and find out where that's going, because one of these two should go to that anode, and one of them should go to the heaters. Now the DL94 has a 3-volt heater tapped into two 1.5s. The tap is on pin 5. So no, there's nothing. Okay, that's okay. The meter's okay. So 2, 3, 4, 5. Okay. And that does now. Okay, right. So again, we'll check all. I'll check all the pins here apart from black. Because we know that black is chassis. Ah, okay. So if we go to the ohms range here, that's hang on, there you go. Can you see that? Yeah. So now we go around and we see that that is 504 and that is 509. Okay, so that is one of the two. Now, with the bulbs in circuit, there should be something across them to one of these pins. Nothing, and of course that. Okay, well, with that in mind, I think next thing we do is we look at these valves and make sure that they have continuity on the heaters. Of all 4 have gone with these, it does happen, and there's not really a lot you can do apart from swear. Or 2.8, okay. No, so that's okay. So that one, the heaters are okay on that one. Okay. More at it. Let's have a wallet and check them, shall we? Now the others, I think not the DL, don't have the same have the same way of taking the heaters. So you know, all you have to do with these is just pins 1 and 7. I put them between my knees here, and with one hand it's easier for me, you know. So yeah, that one's okay. That's me to there, so you can see it too. Okay. Okay. That one's okay, yeah. So that one's okay, that one's okay. This one is the DK, that's the frequency changer valve. By the way, on again on most, 99% of AC/DC or AC only mains radios, it is a triode heptode circuit, a pentode triode circuit, something like that. something like a UCH or an ECH81. With these, it's quite often it's a DK. There are the EK versions as well, and the 8K, funnily enough, and they all do the same sort of thing. So again, it's just a cheaper, smaller way of doing it. That's all there is there. So again, there's nothing untoward there. Okay. And finally, the DF, which is not the easiest valve to get at, but we will get there. There we go. One way or the other. By the way, another thing with these sets, just for the entertainment value of them, is that they have one or two other little quirks which I did make them a bit different to service than the that one's okay, by the way. You get that one's okay as well. So all four of those valves are okay. So I'll put them in the case there carefully, and let's have another look at this board and find out where things are going, basically. So with the meters still on continuity, which is very, very handy in these cases, yeah, we know that again just to check, the heater, that goes to there, and it goes here, and here, and here, and here, and here, and here, and so forth. Just bring the point, by the way, not point. They all look the same. So yeah. So that's something else which you have to be aware of, as it were. Now, right. So I'm going to put that onto red like that. Yeah, and we'll follow red through, and we'll find out where it goes. Yes, I know I could use a manual, I might do yet, but if a manual is not available, this is the way to do it. So again, there is madness in the method. Or method. Ah, okay, so it goes to there. Okay, so that one goes to, put them right the way, right, okay. So that goes to, doesn't now, okay, fine. I think let's have a look at this transformer system here, don't you? Because I wonder if that is where the problem might be on this set. Because what these sets do in a lot of these cases is the set is switched off, and so the lead is raised and it comes on straight away. And these switches do give problems very often. So that is the first port of call, I think. this side here, and so there will be somewhere with this something which that should short together. Yeah, so that goes, they all come out through here, come down here to the switch here, and let's see if it's we'll see if it's here. Another thing to do, by the way, these is you put a system in place whereby the radio actually makes a noise when the radio is quiet. It's quiet. So what, hang on, I'll just be back in a sec. Right, now I'm taking the screws out, the speakers out, and so now we can lift that completely out of it, and the case can and all the screws inside the case, and that can go somewhere out of the way. So now it's just the case. No valves in, of course, because I want to check everything where it should be first. And also, I'm going to give the Wavechange switch a bit of a squirt spray, because it's actually this particular set I've found out is one of these where it actually is the spray itself. So switch it to medium wave, and again we'll sort out what is where. So now again that goes into there like that, and yes, and turn this round like that, and we'll have a little look around here again and see what we can find. Okay, right, so the red goes now to the output transformer, and as you can hear from that, the speaker is working all right, and of course that's the screen good too. So this lot here, this is the 8T side of it, which by the way does not go to deck because there is no current, so it can't do. So black and red therefore are the heaters. Sorry, black and red therefore, which I'm twisted together here, are the 8T. Okay, so now, so black is 8, is 8T to deck probably. Now these two therefore will be the heaters, and so I'm going to assume therefore that yellow goes to the heaters. And it seems to. Those black, those brown therefore go to the other heater pins. It does. Okay, so yeah. So therefore now we need to find out which one of these it is heater ground. So what we do is we have that goes onto there as 1 ground and 2 and not another one of these. Aha, okay. Yeah. So therefore we have the fun. We have black and red are the HT pins. Yellow is heaters minus, and brown is the heaters plus. Okay, so we now know from that which is which, and just because my memory is getting rather bad these days, I will find my pen and scrap the paper. It's not got something going on it already, and write that down for future reference. Right, so with that matter stored away, we now get our little power supply here. Very nice bit of kit this actually. And this one I'm going to do here, I'm going to plug it in and find out which are which on here. And I know I should know, but I probably do, but it's always worth checking. So again, check, meter goes on to 200 volts, okay, and that goes on to there like that, and this goes on to here like this, and we should see 90 volts or 1.5, 90 volts, okay. So black and red go to black and red, okay. Now these two are the heaters. I think green is negative, I think, but we'll check, because green is a lot more negative in my eyes than yellow. So it is okay. So we know from that what goes where. So what we do now with the heaters out is we go we go red to red like that, black to black like that, these leads are, these crop clips by the way are not the easiest to work with, but these things do matter. Now here, yellow goes yellow here and green like that, and yellow goes to brown up here like that. Okay, so that's the and we'll see what happens. Nothing, no smoke either. That's as good, isn't it? No smoke either. Okay, right, now then. So now I get the time to start putting valves in one at a time and seeing what happens, if anything. So with that out circuit now like that, we now come over here and get a valve to it and put them in and see what happens. Probably nothing, but you never know, do you? Especially if you drop them on the floor. This could be one of those days, obviously. Right, okay, so that's DF, okay. That's DL. I'll put the DL in its socket and hope it survived its fall. Yeah, just rub these rubber bands out of the way for a minute and put the DL back in its socket. And switch on and see what's nothing. Okay, not to worry. Well, again, at this point now, I'm going to go under chassis like this, and I'm going to look at this. Put that back in like that. Yeah. And I'm going to do the old trick with the meter probe and see if I get any buzzing anywhere. Which we don't. Okay. So that goes to deck. I'll have a look round here again. We'll find it. We'll find out which one I'm going to put where. Like that. Okay. Down slightly there. That's good because the valve is definitely doing something as regards conducting. So that's okay. That's okay. Okay. And fill it down here. That's doing something. And I'm now going to go and look at the heater chain again. Here, first of all, like that. And of course here it should be that. Okay. And of course here there should be very little, which there isn't. Oh dear. Right, okay, well. Well, the speaker's okay, obviously. Okay, that's okay. Okay, so this one goes to somewhere like there, which it doesn't. Okay, fine. Doesn't go there either. Something there, but obviously not anything that we want. So again, we go on the other side like that. That's okay, and that's okay. But this side, it doesn't seem to be. Okay, right, okay, not to worry. Lifting that valve out again very quickly. Like that. And we'll check and see what I think we'll go across those and see what. And see anything else going across those. There shouldn't be, but you never know. Nothing. Okay, so nothing to there. That's not right. That is not right. That is, this isn't. Okay, what we'll do therefore is we'll go on all the pins and see where this will go onto there. Into there. Onto there. Okay, so that's brown. Okay, so brown goes to them. Okay, so therefore okay, supposing I was to go from there to there. Okay, well in that case, is it black and brown for the heaters? Have I got this the wrong way around? If they do, by the way, then the 5 ohms resistor in between the two, so that might be the problem. So now, where does black go? Does it go here? No, it doesn't. Okay, fine. Hang on. I think that might help matters, mightn't it? So that goes onto there. Easy to get confused, by the way. Very easy to get confused. Okay, fine. So it's black and brown for the heaters. Okay. So what I wrote down just now is wrong, but never mind. Black and brown for the heaters. Let's do unravel them like that. So black and brown for the heaters. Okay. Therefore, is HT ground, and red is positive HT. So we'll do this again, shall we? Right, so therefore, with that in mind, brown here goes to green here. Brown here goes to green here. And therefore, yellow here goes to brown here, like that. And if I was to now plug the thing in, we should get voltage on all the heaters. Hang on, let me put it in properly. There we go. We should get 1.5 volts or thereabouts on the heaters. Let's see if we do, shall we? Put them right there for a minute. So, now we should get something either there or there. So 1.39 there, and over here we shall get 1.39 somewhere like there, we do, and there we do, and of course there, and we do. Okay, so that's the heater. So therefore, taking it a stage further now, with these multicoloured connectors, which, by the way, there was a case recently where Chris, all the gear and no idea, was mucking about with ohmmeter like this as well. The best way to know for sure is to look and test and find out like this. Okay, this wouldn't affect the valves, because all it would have done is make the heaters run a slightly less current. That is all it would have done. That's all. So now we have plug it in again now, like that. Let's see what we get here. $94.8, $89. Okay, right. So now let's put in a valve and see what happens, shall we? DL96 into BL96 socket here. Now you can't hear it on the speakers, but there now is a very slight hum at that speaker. So So back to the DL96 socket again on here, and it's pin number 6, which is this pin here. Which is giving us something, not a buzz, yeah, very, very slight buzz. So we know therefore that the DL stage is now okay. But there's a capacity here which must be changed, but we'll come to that, okay? So now we go and find a DAF, I think it's the DAF96, there we are, and push it in the radio. Right, well, seeing as it's a better day, I'm not so tired, let's, before I put the DAF96 in, I'm going to show you something about these sets, and it's something which you really ought to know. On a normal valve radio, a mains valve radio, without these valves in, the first grid of the pentode is held below negative to the cathode, yeah, and from there the audio gets through, but nothing else should. That's what that capacitor does, yeah. That's in all sets, yeah. Now, on a normal valve radio, the cathode is held at like 10 volts, 15 volts, something like that, and the grid is held at 0 by that capacitor, like I said, yeah. On these sets, it's a directly heated cathode system. That means that the cathode and the heater are one and the same, yeah. So the heater and the cathode will go to 0 volts, okay. So what I hear you say? Well, therefore, in order to get the cathode at 0 and the grid, first grid, to be lower than the cathode, the HT side of it, the negative HT, is held at about 7 or 8 volts below Earth. So basically, compared to Earth, which is of course the black lead here, of course, yeah, which is the valve heaters as well, yeah. With that at 0, yeah, the HTs will be at negative to that, yeah, and there's a 500 or so ohm resistor between the two that holds it in place, yeah, 500 ohm or so resistor. I'll get a circuit in a while and I'll show you on that, okay. But with that in mind, there are in fact 2 HT supplies on here and 2 separate voltages, yeah. This means that if that capacitor allows any voltage through at all, positive voltage at all, it will shut up the radio, okay. It will shut up the radio almost completely, because the grid has to be below the cathode, yeah. That is why in these sets it shuts the radio up completely. In most cases, if I put that on, put that on now, you see like that, and switch on, which is what I've done, yeah. That one is there. So there should be a difference between there and there. which as you can see there is minus 9 volts. Yeah? So the cathode is held at minus 9 volts. No, sorry, the grid is held at minus 9 volts. Yeah? Like that. Now, any voltage that gets to the pressure grid by that capacitor actually holds it above that. And so, like all radios, it has to be changed, but in these radios, it can put the radio out of action very, very quickly indeed. So as always, change it, but that is why. Okay, that's a tip from the top. Before anybody else had put it on the wrong side of the panel, when you consider where it was in the circuit, it's not 100% right, but it is prudent. Okay, so now if we plug the set into mains by the power supply unit, which is here, wired up correctly, and plug it in like that. Yeah. Now on the grid of the DAF, there's rather a lot of voltage, as you can see. Oh, there was just now, hang on. So that's okay, right? Now on the other side of this capacitor now, there's nothing. And if we go down to 200 millivolts, again, there's virtually no. So that the capacitor is now blocking that DC voltage. Okay. So with that in mind, just prove a few more points. That's this the anode and the second cathode there. They're okay. And there's a 1.2 volts on the heaters, just to prove a point. So now unplug again, take that away. If I put the valve back in, the DL, which is this one, if I now put this one back in, like so, now, and power it back up again, I can hear a very small noise in the speaker. Very small, but it's there. So, now, if we go onto first grid, that is now a lot more noise there than there were. And it will also be here, the other side of that capacitor. So that means two things. One, it means that the pentode side of it is working, and two, we go further back in the circuit. So DF96, which is another one that's hard to get in its socket, but there we go. We do these things in the end because we have to. So that goes in to there like that, and hope this one works, by the way. And now there should be something on, look, what now? And there should be something like before, and there. Okay, so we know that the pentode and the first IF stage are working. So if we now go a stage further and put in the other two valves, it might even start to talk to us. You never know, do you? So that's a DK, and this is a DF96, which is for those who want to know, an RF pentode or an IF pentode, because I is basically one particular RF frequency. So get it in its socket, which is really got to be more easier said than done, but who said things are meant to be easy? Certainly not me. So that one goes in. And why not put the DF in, the DK in as well? Why not? And see what happens. Something will probably. It'll either not work, it'll either work, not work, or go bang. Place your bets, please. Now, 3, 2, 1. Aha.
In that second place in the group, and as things stand, it'll be Finland, Wales on Saturday. Incredible scenes in St. Petersburg. Finland, plenty of it.
This time. So long way, shall we?
Way to keep in touch with. On digital radio, if you already have a.
Well, it's okay on medium wave, but not on long wave. So we've got one or two things to do yet, then this one can go back in its case and be fixed. By the way, I'll also make up these lead free, Chris, as well. So yeah, so this one is getting there. Okay, getting there. Now, first of all, there's a capacitor in here of a kind which again must be changed. It's this one here. These plastic caps, they're not the best in the world, and this one goes across the HT line. Okay, and because it goes across the HT line, I'm going to change it, because you know it is the right thing to do in this case. So that cap comes out, a new one goes in, and we'll try again, and then we'll look at the what long wave isn't long waving. Look at the size, by the way. The capacitor that's in there, that one, and the 102K, which is a lot bigger. Look at that. Things have shrunk over time, haven't they? Anyway, that can go. Right, anyway, now, plug the thing back in.
Possession. Gives it back to Jason.
And there's radio 5 live, so we know it's still working on medium wave. But on long wave, there is absolutely nothing. Now, a lot of these sets have a combined wave change and an off switch. So, first place we'll look is make sure the power is still there. So, plug it back in again and see whether this thing still has power. If it has, oh dear. Yeah. Oh dear. It does still have power. Okay. That's a shame in a way, that, but never mind, these things are sent to trials, aren't they? So and the also don't forget, of course, with these, the heaters are wired in parallel, so it could be a problem there, but I'm not sure as of yet. So down here there should be something on there. Now that's interesting, because it doesn't appear to be anything on there or on there but switch it back to medium wave.
Come on, and allied with that scoreline,
Just
the
in here there.
in St. Petersburg. The celebrations here in Dublin are underway. Casper Ullman is waving his arms up and down with his black cardigan. He's got a smile on his face because they know nothing now can stop Denmark from going through.
Absolutely not. They've just been keeping the ball for the last 5 minutes. Denmark bouncing it about. Every time a red shirt comes close to them, they pass it to their teammate. Frustrating Russia.
That's
Making
okay.
them concede free kicks. They've been brilliant in this game. They've been paid.
Again, back to long wave. And again, there doesn't appear to be anything going on in long wave, does there? At all. At all. But there is on medium wave, otherwise
For Denmark and the support.
wouldn't do the football, would you? So obviously, therefore, the problem is in the switching of the LT on long wave, which basically puts probably up to this switch here. So first thing I'll do, first thing anyone to do in this situation, give it a little squirt spray and move it about a bit. Like that, okay? And we'll try that again. There still doesn't seem to be anything there. Oh dear. Got to look a bit further with this one, haven't we? Such is life, I suppose. Such is life. Now, we know that with it in the off position, like that, we know that the earths still work. Okay, I demonstrate that by on there and on there. So we know that the earth's okay. Okay, so we've got switch it on one way, and with all the valves in place, it should be something. Well, there is 252 volts. Ohms, sorry, about 250 ohms. That's okay. But on long wave, it appears to be somewhat less, doesn't it? For 43, so it's so on long wave on one it's rather lower than the other, as you can see. 298 volts on medium wave. On 2.29 volts on long wave. 250 ohms on long wave, and on medium wave rather less. Okay, so it does appear therefore to be this switch here. So let's have a little look at this switch, shall we, and find out if we can first of all give it more, because of course it is surprising actually how this thing come to life after a squirt spray like that. There doesn't seem to be much else wrong with it, so yeah. Now also while I'm here, the ADC capacity needs to be changed in this. I know, because on Radio 5 Live just now, it was a touch distorted. So I'll do that while we're at it. Okay. Here is the circuit of the radio in question, the Sky Princess, and one or two others as well. These sets are basically, these portable valve sets are basically the same in how they work. If first of all, LT negative goes to deck, the chassis, okay? Now AC negative goes to chassis via R13, which is a resistor, which is about 560k in this case, yeah? This holds that voltage lower than the chassis, and that is the voltage that is used for the first grid, okay? So that's how that works, okay? Everything goes through that resistor there, okay? That's how that does it, okay? Next thing, that resistor there, that capacitor there, of course, is the one which you have to change as well. Now, every set, nearly every set, has an AGC line, which is this line here. You see that there, yeah? And the capacitor there, which is C5, yeah? Now what C5 does, it takes any noise off this line, and also what this line does, if the set is tuned to a powerful station, it cuts the gain back, okay, and opens it up again for a weaker station or between stations. Basically, the receiver gain varies as need be with change of station. This is so that powerful stations don't overload it, okay? That's why they do it, okay? So that's this line here. It comes from here off the volume control, from there, and it goes to there and to there, and it holds, and basically it cuts the gain of those valves down on a strong station. That's what it does. So that capacitor again must be changed. Without it, the set will whine and all sorts, but with it, if it goes faulty, as in goes leaky, that line will not work properly and will cause distortion, so that has to be changed, okay? So that is how that works. Right, this is done now. This is a Sky Princess disguised as a Berwick Matador. It says something to the princess you took home, Chris, so no problem there. And just to bring the point,
The old adage that team could lose 3 wickets in the power play over.
there you are, working radio.
This is a good project.
So yeah, this one is now working in fine. I'm afraid long wave doesn't work on this. The problem is in the switch itself, and I think in the circumstances it's better off to let's say that some battles are best left unfought, because if the switch gets any worse, then it's something which we can't get anymore. So we'd have to do a lot of mucking about there. So it works only on medium wave, and as you hear there, it works fairly well. Now we're going inside. There are 4 wires there. Black is chassis, brown is heaters positive, that's 1.5 volts, H to negative, no sorry, let's try that again, sorry about that, start again, right, black is H to negative, that's the chassis, brown is LT, that's the heaters. I'll tie those together so that you know which are which, yeah. So black and brown are the LT to the heaters, okay, that's these two, okay, so I'll put these two together like that, and but 1.5 volts goes to those two, okay, that's okay, so that's so that they're there. The O2 are the HT there. The red goes to the HT positive. That's the you can pick that up on the output transformer here, and yellow goes to the HT negative, which is held down by a 560 ohm resistor, which has to be checked on these, otherwise it can cause distortion quite quickly. It's about alright on this. So this one is done. There wasn't a lot wrong with it, but I've changed. There's a capacitor on the input, HT input, which I've changed because it's if it will cause problems. That capacitor I've changed, of course, and also the HT capacitor, which is here, which is not what it says on the diagram, so not for that. Anyway, so those two LT, those two HT, okay? So yeah, so yeah, so that one is fixed up again, and it's ready to go back to you in one piece. So there you are. That one is now sorted and happy. Okay. So on to the next one. This is a Vidor set that's slightly older, but works or will work just as well. It's in very good condition actually, this one. Again, medium wave and long wave, and using the same sort of valves, I think. I'll check in a second on that one. There are two sets of D valves that these use, so we'll check and we'll find out. Now, so look inside it again. You see it's got the usual 4 valve contingent. Hang on, I'll move the camera. Hang on a sec. There we are. So the usual 4 valve contingent, like before, which I will get through again, like that. That does that, which is quite handy. So that is this radio here. Things with it. Well, first of all, there's a few more in-sync capacitors that need to be changed. The valves, by the way, on this are the 9.6 series again, DL96, DAF96, DF96 and DK96. They work in the same sort of way, but this is a Vidor. Now, another thing which you do need to consider with these is that the numbers are okay, but the leads are in fact different on this. Yeah, different. So again, you can't just say it's green and yellow on that set, so it's green and yellow on this, because this one is it appears a different colour set. It's got a different colour set. We've got to find out the hard way again, which is which here before we give it any power. So yeah, so I'll just turn around a bit so I can see it as well as you can. There we are. And again, what we do here, first of all, we get the meter, switch it so that it makes a buzzing noise. Test it, like so. And the first thing we need to look at is the output transformer, because that is where the HT can be done. Okay, so one of these wires down here is HT. Okay, one of them is HT. So go round, and one of them we will find is going to be HT. That one. Okay, so therefore this one, if this goes to ground. Let's check that it is ground. This goes to ground somewhere. How about there? How about there? No, I think this has got some paint, some paint on it to make it difficult to get to ground. Okay, so that's ground. And that isn't. Okay, well obviously one of these is not ground somewhere. Now in this case we've got to look very carefully that which one of ground is most likely to be. If I put that on there like that, yeah, and we come down here, this one should be at 500 ohms to deck. This is the 82 ground, so this one should be at 500 ohms to deck, which can you see that? Okay, so 500 ohms to deck, which it is. Okay, so here those two are the LT. Okay, those two are the LT, which means these two are the HT. So therefore, one of these goes to deck, and one of them goes to deck via valve heaters. So so one will be slightly higher than the other. Okay, so if that goes like that now, you see, that goes to deck, and this one goes to deck. Two valve heaters. You see that? You can check that, by the way, by taking all these valves out, like that. And now, with these out like that, there should be the ground on one and nothing on the other. Okay, so on this set, therefore, black and brown there are HT, and black and brown here are LT. Okay, it's fairly simple. So that's one thing. Right, other things, well, but again, this is an older set, and it's a printed circuit board, and so I've got to look around and find out where that capacitor is, because that has to be changed first. So what I'll do here, actually, I'll go and get a manual for it and come back to you. Okay, so I'll be right back in a second. So this set is a Vidor Regatta water model CN420. I seem to have that bit better. Okay, fine. It's as you can see from the circuit here, it works in a very, very similar way. Very similar, in fact, they all do. Apart from the end here, where on this set, which is slightly older, the aerial is in the lid. Okay, like that other Vidor over there that I looked at recently. So you know, that in the lid takes two coils, L1 and L2 for long wave and medium wave. Okay, the capacitor that you must change is this one here, C16. This one here, C16, and that resistor there holds the bias of the pentode down below 0 volts, so it can actually be heard to speak. And of course, the other interesting capacitor here is C12 there. Okay, so there, the other ones that need to be changed. Also, I noticed with this circuit, actually, this circuit has the DL1, 91 and 94 series valves in the circuit. The set has a 96 series. Whether we put in since then, I don't know. But if we need to switch a switcheroo, then well we can. Okay. So if we now open the set up again like that, you see, and volume got turn it in so you can see. There you are. Volume, tuning, and the Wavechange switch, which obviously need to clean. So we'll do the basic stuff first, change that capacitor, and then we'll get on with powering it up and making it work properly. What this thing is all about. Sorry about that. Right, okay. So now, yeah. Now we need to find out again which pin here is T16 is on. It goes to the anode of pin 3, and it goes to the first grid of valve 4. Okay. This circuit does have the valve circuits on it, and we can see from that it goes on to pin number 6. So find number 6, and there should be a capacitor attached to it, which in this case is 0.01 microfarads. That's simple enough. So we'll find that and we'll change it out. When you go into radio, sometimes you find it's not what it seems or what the manual says it should be. This set, by the way, is a Vidor regatta, like I said before, and the valves in it are different. DL96 on the manual and DL94 in the radio. And what's more, inside the radio it has the 96 series, so this is obviously a later version of the set compared to this here. Also, there's bits missing from this set, and what to the valve holders are a bit dodgy. So in this situation, when there's a lot to do, the first thing I will say to anyone in this situation is don't panic. Do not panic, because if you do, then you know you've lost the job straight away. Okay? Don't panic. And remember what I've always said about PAIR, P-A-I-R, okay? Power supply, audio, IF and RF, in that order. Start at the batteries and work your way out through to the aerial, taking all the scenery on the way. That's how you do it. So in this case now, what we do, first thing we do, having worked out which are which, is hook the meter up to the power supply at battery mains set. Of course, this is battery set only, and in this case you work first of all on the LT, okay, but you don't need your power supply, you use the meter, okay. So there you go. So the meter goes across the LT terminals like that, and you then of course switch the meter to make a ring test, okay, which is what I've already done. So once this goes on here, and these prop clips aren't exactly friendly, with there we are, okay. Now with them together like that, that's 0, okay. Well, with them apart now, you see, we can check every valve and make sure that it is doing the features do work, but do them one at a time, okay. Any order doesn't matter, okay. So okay, well, that's not doing very much, is it? That's the DK96. Hang on. It could be the valve, it could be the socket. So we know that the DK96 either the socket is faulty or the valve is faulty. Okay. Now going on to the DF96, which is the next one on, put it in and see what happens with this one. So it goes in, and again we just make sure that it goes in the right way, and the same applies. Once it goes in, which is dabbing itself with these sometimes. So it goes, and again the meter doesn't tell us that there's much going on. I just check and make sure that it's still conducting okay, which it is. Okay, so the meter is okay, and the this is okay here. So the DF also seems to be something of a problem here. So DF, the DAF, I got a new one because it was faulty. Okay, so I know that valve's going to be okay. So I get another valve. I want to try it in the DAF socket just to see what it does. Yeah. Okay, so that again, we've got the same sort of problem. So what we do now is we get these valves and we check them on the meter. Okay, that's the next thing we do. So what we do, we get the valve. I use my feet like that, you see, and we go between pins 1 and 7. Okay, go between pins 1 and 7. Like on the diagram. Okay, so pin 1 and pin 7, and see if it reads, which it does. So we know that heater's okay on that valve. So we know therefore that the socket is dodgy. Okay, that's that one. Okay, and the DK, same applies. Okay. Pins 1 and 7. In these sets, they are the two on either side of the hole in the pins. Because if you look, you see, there is if you put the valve facing towards you, pins towards you like that, and count round from the left hand side of the gap there, 1, 2, 3, 4, 5, 6, 7. Now the DL is different. First of all, between 1 and 7, there you are, like that. Okay, that checks I think both pins. Yes, it does. But also there's a tap for them on pin number, I think it's pin number 5. So again, pin 1 to pin 5 and pin 7 to pin 5. That's okay. That's back. So therefore we know that all these valve heaters, these valve sockets are faulty. It's a great start, isn't it? It really is a great start. So now we've got to look at sockets themselves. Now, before you change them, there are other things you can try. Usually squeezing the sockets together so they grip the valves. Okay, that's the first thing we try and do. Doesn't always work, but it's a lot easier. A lot easier. And just changing the socket. Changing the sockets is one of those jobs which you only really want to do if you have to. So this one I've just very quickly done because it looks as though it might be okay. I've got one of these soldering tools. Watching my eye very carefully here. There we are. So now we get the DF, put the DF back in its socket like that, and see if it reads now. We know the valve's okay, so it's socket. So on, and still it says it is doing absolutely nothing. So what we do, wiggle the battery around, the valve around a bit in the socket and see if it comes in. If it does, then we might be on the right track. But if not, then this set we're going to have to put aside. First of all, for 4 new valve orders, which I'll order as soon as I can. So there you go. So now that goes back onto there like that, and now we do that. And again, there's nothing. Just to bring the points, the meter's okay. So this socket is well past its best. Okay. Now, I'm inclined at this point. I'll have a session with these and see if I can make them conduct. But every pin has to conduct, of course. So I might possibly have to drill these valve bases out and put other ones in. They can get them, by the way, you can still get them to be there among other places. So it's not that bad of a problem. DF, here we are, DF, right. We know the valve's okay because we tested it. Okay, fine. I'll have a session on these, and I'll order up some more valve bases. So back with you presently. Well, this Vidor wants all 4 of its battery valve holders changing, which is quite common on these. So I'll get them ordered, and this set can go in the racing pile until they arrive. So that goes out of the way, which leaves us onto Chris's third radio, which is an Ultra Transistor 6. Now these sets, sets like this, generally speaking, just work. So there's not really a lot to do with them on that score. But having said that, there are capacitors which need to be changed. But as always, let's get inside and let's have a look and see what is and isn't working with this one. Now, these sets, they have plastic caps on them which tend to wear it rather quickly, and also I think what you hunt as well. So it will need a complete recap. But unlike valve sets, it's not such a problem, although it is wise to do it. Now, the battery that these take are 4.5 volts, but they can't get the batteries anymore again. So to modify it, to take the modern kind, which is what I'm going to do here. Yeah. Now, reading the circuit of these tells me that the transistors that are on these will work at 6 volts, 16 volts. So 4.5 twice makes 9 volts. Now 12 volts is 2 lots of 4. Now that isn't a problem because they'll work okay with that, so that isn't an issue. But what could be an issue here, is the fact that they do sometimes be, shall we say, fun to deal with. These sets, what they do, they don't have an output transformer. Output transformer, these sets, you don't have one. They have an intermediary, which is there in the circuit. It's there, you see, and that's in place as normal. But as far as the other end goes, well, they don't. So they do, and they avoid that by putting the speaker between two cells of the same voltage. Yeah. I'll get the circuit in a minute, but they are quite. It's quite a simple circuit. Also used on the deck of debonaires, which I know I had one of those in recently. It's behind me. So it's the same sort of circuit. Well, as I said, these do not have the AF transistors in them, so there's no problem there. But again, they do fail sometimes, so that's always worth looking for as well. So really, sets of this era, so a number of them actually use transistors in like valve circuits such as push-pull, and this is one of them. It's a model TR100, and I think it's got things in it which my for one wouldn't be too happy to deal with it, but there you are. So what I'm going to do here, I've got, especially for this radio, in one of these, here we are, two of these battery containers. That's these, yeah, two of those, yeah, and we also have two of those. Okay, now I wouldn't recommend feeding this with two PP3s because the resistors, the stated value of them, the stated voltage of them is 16 volts, and two PP3s make 18 volts, or maybe a bit more when they're new. So it might be all that good for the transistors, but you know, that's the way it is. So we've got a set here with wires iron off it, one of which doesn't seem to be here. So where that gone, I don't know. And of course, the first thing I will do therefore is get the circuit and we'll have a look at the circuit together, and then we'll I'll put the batteries in place, put batteries in and see what it does, what it doesn't do. Transistor sets aren't quite as dangerous as valve sets. I've never had a transistor set or a valve set for that matter that catch fire, but certain rules apply. So all these plastic capacitors with the yellow around them, they all have to come out. They're well past the sell by date. There's one or two hunts in this as well. But what we're going to do here is get this one working, then he can do the rest, because he is learning the trade, and I don't want to do everything for him because I don't. Besides, he wants to learn, so learn he must. Yeah. The set itself is medium wave and long wave. Nice dial. Volume control, it's very nice, and it's actually. And the case, again, he wants to do it himself, so can't spoil all his fun now, can we? Or can we? One thing which we will do before we start getting battery up to think is make sure the on off switch is okay. It's in the on position, and this actually has two switches on it, so that's one, that's okay, and the other one goes on the red to the other yellow, rest of the set, which goes to here. That's okay. So we know the switch is okay. Now, I think with this actually, the brown is the middle lead that goes to the speakers and stuff. So I wonder if this lead goes between the two, as it were. So the two 6-volt batteries are wired in parallel. One of these goes to chassis deck or earth on this, and the other one goes to either negative or positive. A lot of these early transistor sets, they are positive ground, so do watch out for that, because if you don't, it could be expensive. Could be very expensive. These transistors, you can get replacements for these transistors even now, but the original ones probably not. Russian ones do fit in their place, and the Chinese ones, but they are getting expensive, so it's always wise to avoid necking up transistors if you can. Some of these, by the way, have Business Roberts ones have it doesn't this has actually has resistors, capacitors, and also a thermistor or a thyroid in place, which varies current at switch on. So if one of those dies, you can still get the best of the current. Wonderful place like online. You can get all sorts, including those. So yeah, right. Well, let's get the manual, have a look, and wire it up. Here is the circuit of the set in question, and as you'll see from the circuit here, we'll get a pointer, there we are, there's no output transformer. There's an intermediate transformer which is there, but there's no output transformer. Instead, it's 4.5 volts between there, and also 4.5 between there and there. Okay, it's going to go to 6 volts with these. The set will take it, no problem. And of course, if you put rechargeables in, that's only 1.2 rather than 1.5, so that will drop it down again if we want to go that route. So, also, with it being a germanium set, it's positive ground. Positive ground, and so rather than risk doing anything really stupid, just for once, you know, because I'm like that, well, what I'm going to do is put that on there like that, put my glasses on, because I'm getting old, there we are. Yeah, and again, the meter is on the ohms range, so I don't need to look. I just I just that, you see. So therefore, okay, so that goes to there. This goes to there, and also looking further at the circuit here, we can look at the IFTs as well and see. Yeah, so positive ground. So therefore, one of these goes from ground to here, the middle one, and one of them goes from the middle one to negative, which is well, in a way, positive in the circuit receiver. So that goes to positive on there, you see. And there's a resistor R14, which is 270 ohms on the circuit here, which is which I can find on this circuit, but which also has a diagram. And from that, I can find out which one is right. That one there. Okay, so there should be a resistor somewhere around here. R14. If there is, then we'll look at that one and we'll find out exactly what it is meant to be. So R14. That one there. So now you should get something between there and say, bit able to get up, bit able to see actually. There, and I don't know, say there, well, something there, and there. Okay, so then we know. Now we know from that which way around the batteries go, which is important. Also, by the way, there's a large capacitor across the speaker. I'm going to cut that as well, because if it goes short circuit or something, we won't hear anything. So whip that out, because it could be changed anyway. And on the circuit, I get the circuit back again. You see, there's the speaker, and there's the capacitor above it there. You see, so that's there at the circuit. Okay, so now we know what we're doing, and so we do it. Okay, so red to red, black to brown on the first one, and then on the other one it's red to brown and blue to black. Power supply wired up and switch on and see what happens. What a crackle. Volume control. Obviously something getting in. But not stations. No stations anywhere. Okay, no worries. In that case, let's have a little look around so we can find out what is where and what is not where, what should be where and what shouldn't be. So now, first of all, to deck, they should be there, which we are. Okay, and to the other one, there should be 12 volts, which again there are. I just put that way you can see it. Okay, right, so now that should be reading 0. It will be. Up here should also be reading about 12 volts or thereabouts, somewhere like there, and it is doing. So we know the power supply is all right. Now at this stage, I'll quick look at the circuit. What I'm going to do is try what's called the halfway split method. Okay, rather than mucking about with the input on the, which I think I'm probably working on this. I will go to the volume control. Hang on. Is a diagram with a circuit attached to it as well. And so what you do, this is the circuit, how it's wired, and this is where the components are on the board. Okay, so it's fairly simple. So the volume control is there, it's VR1. Okay, so therefore let's have a look at TR4 and see if there's anything happening there that maybe it should or maybe it shouldn't be. So which one is TR4? And that's to be at TR3, and that's TR4. Okay, so let's have a little look around TR4. TR4 base to be precise, but we'll check all three. Not the easiest thing to see, is it? Okay, where's that passage that was attached to it? C17, C17, C17. Is it same number on this one? Yeah, it's C17. Okay. So C17 is the one. It's this one here. So 1.72. Okay. Next point I'll look at here. I know this is a bit haphazard, but it does work. There's a diode here. Again, we're not getting anything, not even any hum, nothing on this, so there's something up somewhere. Okay, not to worry. Nothing we can do at this point is power up the serial generator and see what, if anything, can be heard. That was up full. Now, with the serial generator at this level, what I'll do is I'll put that near there, and see what, if anything, we get. Because there, hang on, I'll go into the higher effect at this stage. And there appears to be nothing. Again, like I said, there should be something that close. There should be something that close, and there's not. So, so the IF isn't there. If it's not there, chances are it's the 8 plus stages. So I will therefore switch off the unit very quickly and have a look at these 8 plus stages, hoping that transformer is okay. But if it's not, then we might have a little problem on our hands, mightn't we? So. Right, I've got this set out of the case, and I've also managed to prove the amp circuit is okay. So transistors 4, 5 and 6 are doing something. The C17 is in series with the volume control, and it's one of these which often gives trouble in many sets, so it's the next place you look. Okay, so now you see, if you listen there, do clean up, but now there is in fact sound from me going forward, so it's doing something which proves that that lot is okay, not perfect obviously, but okay. Now also, if I switch it on, we can also prove that this is 15 and 16 are more or less okay. 1.7 volts. Okay. Now, if you turn it off again, to the way it is, always that way. Okay, fine. Now, the transistor isn't in the way, but we know therefore that's doing something. So that capacitor is out of circuit now, and so we know that's okay. So we look further back after changing that capacitor, obviously. Now, all these are going to have to be changed. So, but I won't do them all straight away because I want to find the fault first. Okay. Then and only then do we start changing capacitors willy-nilly. Okay. So now I've got to get this board off here, which should be interesting because it's probably never been off in its life. And of course I'll change all these caps as well. This one, and this one. And then we'll look on the volume control and see what there is there. Okay. Now I've got the AF sorted, possibly the IF, but near the RF. I'll say that because on the AF section I've replaced 2 capacitors. One feeds back to the AGC, which is C14, and one of course goes across the volume control. Both of those have been changed, and the dial 2 which wasn't working. So if you look at the circuit here, you see now, so get it in where you can see it. There we are. I've changed that dial there, and that capacitor there, and that capacitor there. Now, what that's done is made the set come to life, sort of. As you can hear. Somewhere among others, as there, you can hear this music. But there's more stuff wrong with this as well. First of all, Wavechange switch here. I've sprayed it, but it's not doing too well. So I'll give it another spray. I'll take it apart and give it a clean. Now, in regards to all the noise on the RF signal, the thing is, on IF it's not there. On IF it's clean. Clean right across the board, which I can prove to you by switching the signal generator like that, and putting the signal generator on the unit like that, and also like like that, switching back on. And as you can hear, that is clean, and that's as low as it'll go, by the way. So the IF appears to be fine. Only appears. I'll say only appears to be, because an oscillator is basically an amplifier that feeds back. For example, if you use a tape recorder and put the mic through close to the speaker, you get a whole around. That is feedback. That is basically an oscillation. That's how it works. And so the problem is either the AGC line cap here being faulty, which is very common, and also possibly these need to be changed. Now, I'm going to go first of all for the AGC cap on this, which is on this one capacitor number 6, which is that one there. Okay, this line here, yeah, is the AGC line, and what it does is, and this set is on a strong station, it takes the IF gain back. When it's on a weak station, it brings it forward. Okay, that's what it does. And also the cap here, which when out of circuit, does make a radio howl in this sort of way. So I'll go for that first, and possibly that one, and that one. Okay, they're I think the Hunt caps, which yeah. Although having said that, Hunt caps do tend to not give us much trouble on transistor sets as they do valve sets, but I'll change them anyway if I need to. Then with everything working properly, then I'll go through and change the rest, because I've then found the faults as well. You know, there are some sets which I've determined to lead you on the trip to various faults, and the various other faults appear as they're working on them, and this is such a set. First thing I did, a capacitor change in the IF stages, which made no difference whatsoever. The Wavechange switch was so troublesome that I took it out of circuit and wired it for medium wave only. And now at this point, we've got, well, something, as we'll see here.
Her sheer athletic qualities, her movement skills, her racket hit speed, her mental agility and stamina are all qualities that she had at a younger age. And I only worked with her briefly for about a year or so, and a number of other coaches in our performance program worked with her before that as well.
Not very sensitive, but then again, I noticed there's no background noise at all, nothing, as if only certain stations are getting through. Now this could be for a number of reasons. First of all, the two battery packs have to be more or less the same. That is the way it is. Yeah, that's one thing. The other one is that it's a feedback loop as well, and a 22k resistor and a 6.8 ohm resistor and a 6.8 ohm resistor in series with both of the 8-put transistors, as we'll see there. And so basically the speaker goes in the middle, as it were, to change the output to deal with an output transformer. This means therefore that both have to be switched off, otherwise this thing will not work. Pity therefore that this control is also now showing problems and has to be taken out and either repaired or replaced. It's a 5k pot. If I can't get 5k, I get something bigger that'll go in and stick a resistor across it to bring it down to about 5k. That's how you do that. It's quite simple. It's one of those things that you do, and it does actually work. So that's not a problem. But for now, I've left one out. So for now, switch on and off with these battery packs here. Okay. So that's where we're up to with it. I also want to change the two diodes on it as well. There's two diodes in this. One of them is to bring up the station, the set on a weak station, and the other one is a detector. Okay, Now, if I was to knock that out like that and put these in, if I touch this down with my finger, I do get a signal of sorts. Now, I don't know how good it is, but I get the feeling that it's maybe got a bit worn and is past its best. The other one, by the way, the sealant is fed back to it, and should be kept at 0 volts across it. That's the other one. That's AGC basically, and gain control. So I'll change them both, and also change any other capacitor I might find that might be a problem. But I'm rather more concerned actually here about these two resistors here. Okay, so I'll look at those as well while I'm here. So what we do, get the thing completely off, yeah, and well, so to ground on one side of this, one side like this, which is to something like there or there, yeah. Okay, so now if that goes on like that, we should have nothing there, and we should have .7 there, so that's okay. And the other one is also, I hope, in the same area as well. So I will check that one as well while I'm here. That's this one here. These two on the side of the board here. Okay. So it's that one onto there, and let's see what this one needs. 7.1. That might be just a little. One's a bit low, one's a bit high, but I don't think it will create the distortion that this was causing. The transistors, again, if need be, I'll take them out of circuit and check them. But I do think that they are okay because they are doing something. So the next thing I'll do is change the two diodes and see if that makes it sound any better. That's this diode here, which is the one on the circuit here. Yeah, and diode 2, which is this one here on the AGC. Okay, so I changed those two, and then we'll try this set again. After also resolving the antenna connection because they weren't too good either. A simple set, maybe, but a plethora of faults. Now, most of the faults on this would not be corrected by doing a capacitor change. Bear that in mind. It was the detector diode, and now you see the difference. You see it there, yeah. So now, the next thing we've got to look at is this on-off switch here. With sets like this, you can't just short circuit one half of it. You can't do it. And the reason for that is because actually it takes a feed from the middle of the board battery packs to feed the output stage. And so both positive and negative have to be off when the set is off. That's the way these sets are. Like I said, that deck was the same. So now we've got to look at this. Now, the Robert sets I have are on-off Wavechange, which is a Roberts thing, you know. So I can't really recommend or think about dicking one off that. So I'll have a look around and see what's available for me, and or possibly I can try opening this up, and I'd rather not do that. I'd rather fit a new knob. So I'll see what I've got. Yeah, like I said, Robert's sets tend to have on-off wave change rather than on-off volume or on-off tone. So Robert's set you can't really use. Other things, well, have a look what I've got, okay, and come back to you. With that sorted, a matter of putting this back on. By the way, it's now a medium wave set only because the Wavechange switch was knackered as well. With this set, I did a capacitor change all the way through virtually, apart from one which I'm not going to bother with because it's okay without it. And it didn't make any difference whatsoever. All the faults on this were things other than capacitors, all of them. Which rather proves a point, doesn't it, about capacitor changing. It's not always the be all and end all, and frankly, you should never do it without looking underneath as well. The switch knob came out in 2 or 3 pieces, as you can see here. Yeah, so that goes into file 13, and then we'll look at this switch here and see what we've got that will do in its place. Then I suppose we're all done really. Right, this set is back together.